Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the domain and range of these given functions. So let's start with the first one. So the first given function is h at x equals 1 over x squared. Now 1 over x squared is a rational function because the variable x is in the denominator. Now we know a rational function can have horizontal or vertical asymptotes. So we should start our analysis by finding the horizontal and vertical asymptotes for this function if there are any in this function. So let's start with the horizontal asymptote. Now in this rational function, the degree of the denominator is 2 and the degree of the numerator is 0 because there is no x term in the numerator. So the degree of the denominator is higher than the degree of the numerator. As a result, the horizontal asymptote of this function is at y equals 0. So whenever the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is at y equals 0. Now we can find its vertical asymptote. Now the vertical asymptote exists at x values where the denominator become equal to 0. So in this rational function, the denominator is x squared. So we set the denominator equal to 0 and solve for x. So for that, we should apply square root to both sides. So the square and the square root on the left side cancel each other out, and we get x equals square root of 0, which is equal to 0. So this is the vertical asymptote in this rational function. So now we can write the domain and range for this function. Now for domain, we have to consider the vertical asymptotes for this function. So the vertical asymptote is at 0. So that means the domain of this function can be written in interval notation as negative infinity to 0 and then union 0 to positive infinity because the graph gets broken up at x equals 0 due to the vertical asymptote. Now in the other notation, we can write the domain as xer, then x cannot equal 0. So this is the domain. Now we can write the range of this function. Now for range, we have to keep in mind the horizontal asymptote. Now the horizontal asymptote is at y equals 0. Now the other thing we have to keep in mind is in this function, the y value will never be a negative number. So if we sub in x as a positive number, the whole fraction will be positive because x squared will be a positive number and 1 over x squared will be a positive value. And if x is a negative number, then x squared will become a positive number, and even then the function value will be a positive number. So that means the range will be all y values greater than 0. They cannot equal 0 because there is a horizontal asymptote at y equals 0, and they cannot go below 0 because the function has a square on the x and there is no other x term in this function. So the range will be 0 to positive infinity, and 0 is not part of the solution or the range because there is a horizontal asymptote at y equals 0. So in the other notation, we can write the range as yer and y is greater than. So there's a very important concept you need to understand and memorize about this type of function. So now we can analyze the second function p at x. Now this is a square root term So there is x square minus 5 under the square root. Now we know that square root only exists for a positive number or 0. So that means the expression under the square root should be greater than or equal to 0. So this is the inequality we have to solve to find the domain for this function. So here, we can isolate x square by adding 5 to both sides. So the 5's on the left side cancel each other out. So we get x square is greater than or equal to, and 0 plus 5 is 5. Now we can isolate x by applying square root to both sides. So the square root and the square on the left side cancel each other out. So we get x is, now since we get plus and the minus case on the right side, so we do x is greater than or equal to square root of 5, or x is less than or equal to negative square root of 5. So the reason why we get this other case is because when the sign of the square root of 5 changes to negative, the inequality sign flips. So that's why we get these two cases. So x is greater than or equal to square root of 5, and x is less than or equal to minus square root of 5. So now we can write the domain. So the domain for this function in interval notation will be, so negative infinity to negative square root of 5, and square root of 5 is part of the domain, and then union square root of 5, the positive square root of 5, and it's included in the domain, to infinity. So that because we got x is greater than or equal to square root of 5. Now in the other notation, we can write the domain as xer, and then x is less than or equal to negative square root of 5, or x is greater than or equal to square root of 5. Now we can write the range. Now we are given the function as square root of x square minus 5. Now since the expression under the square root will always be a positive number, so or 0, the square root that we'll get will also always be a positive, because there is no negative sign on the square root and in the front of the square root. So that's why the range will be, so in the interval notation will be, so 0 included in the solution in the range to positive infinity, because whatever result we get for the function value will either be equal to 0 or greater than 0. And in the other notation, the range will be yer, and y is greater than or equal to 0. So now we are done with this function. Now we can move on to the next one. So the next function is a parabola that has its maximum value at y equals 5. Now for a parabola, the domain is always all real numbers. So in the interval notation, the domain can be written as negative infinity to positive infinity. So there is a very important concept you have to keep in mind for the domain of a parabola that has no given restrictions. So in the other notation, we can just write the domain as xer. That means x can be any real number. Now for the range, we have to identify the direction of opening and the maximum value or the minimum value on the parabola. Now since this parabola has a maximum value, so if I have to sketch this parabola, so I can sketch it like this. So it has a maximum value. That means this parabola opens down, and then the highest point on the parabola is at y equals 5. So the parabola looks something like this. So this is just an example. We don't know where exactly this parabola is located on the xy grid. So for this kind of parabola, the range in the interval notation can be written as, so negative infinity to 5, and 5 is included in the range because 5 is the maximum value. So that point 5 lies on the parabola. Now in the other notation, the range can be written as YER, and then y is less than or equal to positive 5. So now we can analyze the last function. So it is a parabola that has its minimum value at y equals negative 3. So as we discussed earlier, the domain of a parabola in interval notation is always negative infinity to positive infinity if no restrictions are given about the parabola. And in the other notation, the domain will be just XER. Now for the range, we have to analyze the direction of opening and the minimum or maximum value. So in this case, this parabola has a minimum value. That means this parabola opens up. And the y coordinate of the vertex is negative 3. So one possible parabola that can be sketched for this problem is like this. So as we can see for the range, so this parabola contains all y values starting at negative 3 and going higher. So the range for this parabola in interval notation will be from negative 3, so and negative 3 is included, so we'll have to use the square bracket, so negative 3 to infinity. So for infinity, for positive and negative infinity, we always use the parentheses. So this is the range in the interval notation, and in the other notation, the range will be YER, and then Y is greater than or equal to negative 3, because negative 3 is the minimum value of the parabola. So these are the steps you have to keep in mind to find the domain and range for these different types of functions. So it's very important to analyze the function carefully and then identify the domain and range for it. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.